All right, it's a new morning, a new week, and we're going to talk about gases, which is, I forgot to write that. Oh well, chapter 6 in your textbook. We're going all out of order. There's a reason for it, but it doesn't really matter, especially not now. Before we get going, I just want to say that I miss seeing you guys' sleepy faces in class. Smiling faces in class. This is just not the same, and I wish we had class together, but we don't. So we got to keep going with this. We have lots of chemistry to learn, even though there's only 3 weeks left. So gases. Gases are what we call the expanded phase. And by that, I just mean they take up more space. So liquids and solids, they take up a similar amount of space to each other. You know, an ice cube, and when that ice cube melts, they're very similar in volume. Not exactly, but similar. Gases, huge difference in volume. Okay? Mixtures of gases are homogeneous. We haven't talked that much about solutions, but we will in the next chapter, I think, or 1 or 2 chapters. But you mix oil and water, you guys all know they don't mix. They're not, it doesn't form a homogeneous solution. Gases, you mix nitrogen and oxygen, or any other gas you like, they become homogeneous mixtures. They mix completely. And that's because they are expanded and they don't interact with each other. And they are also compressible. Solids and liquids are not compressible. That's the reason hydraulics work in like a tractor. You can pick something up using liquid. And you can do that to some extent with a gas, but it requires a lot more effort. But that's why we can fill our tires and our cars with air. Okay? And gases exert pressure. What is pressure? Technically speaking, it is force exerted per unit area. Well, what does that mean? If we look at an equation of pressure, P is equal to F over A, where P is pressure, and we use the unit, the Pascal. I'll define that more in a second, or PA. F, of course, is force, and then A is area. Force measured in newtons, area measured in meters squared. That's the SI units. Okay, and that gives us 1 Pascal is equal to 1 Newton. Let's write it like this: 1 Newton per meter squared. Or we could write it another way: 1 kilogram per meter times second squared. Okay, those are all units of pressure. And you know, we probably aren't going to use pascals very much because it's a very, very, very small amount of pressure. So let's talk about what we will talk about a lot, which is atmospheric pressure. So we're all under atmospheric pressure right now, hopefully, unless you're in space. And atmospheric pressure, that just comes from a column of air stacked up above you. You don't notice it because it's always there. And we give this the abbreviation P sub ATM. All right, but a 1 meter squared column of air. And what I mean by a column of air, that means from sea level is the normal place we measure it from, but from sea level all the way up to the top of the atmosphere. 1 meter squared, that's about 3 feet by 3 feet. Take a column of air all the way up to the atmosphere, guess how much that weighs? It's a lot, because you wouldn't think of it, but it's just air, but it weighs 10,000 kilograms, which is like 22,000 pounds. So what is that, 11 tons? Okay, so that's pushing on every square meter of the surface of the Earth and every square meter of you. And I won't go through all the math on this, but the pressure that exerts P sub ATM is 1.01 times 10 to the 5th pascals, or often this is just written in kilopascals, 101 kilopascals. Okay? And that is atmospheric pressure. So I think that's enough for this video.